So this video, everybody, is going to cover circles. I forgot to change the title, but this one's going to be about circles, the formulas for circumference and area, where those came from, and then just doing some examples of finding those things. So our formulas, I'm not even going to bother pretending that you don't know these. You should know these. If they're not on your sheet already, go ahead and put those on your sheet. The formula for the circumference, which is the distance around a circle, is just perimeter in terms of a circle, is 2 times pi times r. Couple things that you might want to know. Circumference has the same root word as things like circumnavigate. So when you learned about Magellan in history class, he circumnavigated the world. Circumference is the same root word there. It also can be written just as good as, instead of 2 pi r, writing it as pi times diameter. Remember, diameter is just the distance all the way across. So the 2 times r just makes diameter. Right? This is a diameter right here, and the diameter is equal to 2 times the radius. Not something you would ever really need a formula for, just something you got to know. Radius is halfway across, diameter is the whole way across, so it's twice as long. Good things to know about circles. And then the area is pi r squared. Right? We'll talk about why that is in a little bit, but make sure those formulas are on your sheet. First big thing is, well, what the heck is this pi thing? Why is the circumference 2 pi r and the radius is pi r squared? One thing I always like to tell people is asking why pi shows up in the equations for circles is really the wrong question. Pi is defined, the whole where pi came from is from circles. So if you take the circumference of a circle, you measure that out, and you take the diameter of a circle and you measure that out, and you divide them, that is pi. That is where that number pi comes from. It's not that the circumference formula happens to have a pi in it, it's that circumference is, or pi is from circumference. It's really the other way around. And you can even do this on your own if you wanted to. So if you took something circular, ideally it'd be perfectly circular, but whatever, so something like a plate, and you measured the circumference, you have to use a flexible tape measure. And so in this case, we get 82 centimeters. And then you go ahead and measure the diameter straight across. In this case, I don't think you can see that, but it is 26 centimeters. And you just divide these. 82 centimeters divided by 26 centimeters. The centimeters cancel out, which just shows you that pi does not have any units. It is just a number. And then I can go ahead and grab my calculator. And all I've got to do is take 82 divided by 26, and you'll see we get 3.15. Now, pi is actually closer to 3.14. I can just go ahead and put that in there, but that's just a limitation on how accurately we can measure. There are other ways to calculate pi more accurately besides actually dividing circumference by diameter, but that's what circumference is. So that is approximately pi. It's not exactly pi. So just one quick example here. Let's say we wanted to find the circumference of that circle. Just like always, I'm going to suggest that you write down the formula first. Circumference is 2 pi r. Make sure we've got that. And then I'm just going to go ahead and plug in everything in that I know. I don't know the circumference. That's what I'm finding. So 2 times pi times 5. And this is where you've got two paths. You can go approximate or nearest tenth, or you can go exact or in terms of pi. So in a real life situation, we'd rather have an approximate answer to the nearest tenth. All you've got to do there is just type it in your calculator. So if I go ahead and grab Desmos real quick, I'm just going to go ahead and type in 2 pi 5. Desmos knows that as long as I'm not typing numbers next to each other, it means multiply. So I've got 31.4. Rounded to the nearest tenth is 31.4. In math, we would rather have an exact answer because what we just had there was not exact. We rounded it to 31.4. In math, we do like exact answers, just like we talked about with simplifying square roots and things like that. when we want in terms of pi, we still want to simplify it as much as possible, but we want to leave the pi in there and not actually type the pi button on the calculator. So in that case, what we're going to do is we are just going to multiply the things we can multiply and leave the pi alone. So I know that 2 times 5 is 10. And I'm just going to leave the pi where it was, 10 pi. And I'm going to leave that as my answer. That's the exact answer. This one was rounded. It is not exact. This one is not rounded. It is in terms of pi. It is exact. In math, we like exact answers, but I think you could probably see why if we were using this for something in real life. 10 pi is not a good solution. If we were trying to, put a border around a circular flower garden, nobody wants to hear I need 10 pi meters of edging. We need 31 meters of edging, right? That's much more useful. The last thing I do want to talk about here is units. The radius was in centimeters. Circumference is just the distance around the outside. Distances are measured in linear units, just like the circumference, or just like the diameter is. Right? There's no square units here because we are not we're not taking a length times a length. There's only one length dimension, and so this is still in connect. Here, maybe. Okay, come on, pen. Okay, so in this case, I would just still have centimeters and centimeters. So those are length dimensions, not area dimensions. Okay, from there, we want to start talking about how to find the area of a circle. And we know the area of the circle is pi r squared, but why is that the case? So here I have a static version of this, but I'm going to go ahead and click on this and show you a more interactive version and explain it about what's going on here. So I'm going to go ahead and pull this up and full screen it. And here we've got a circle. It's got a circle with a radius. First thing I'm going to do is just unwrap the circumference so you can see it. At the bottom there, that is the circumference of the circle. It is 2 pi r. Okay. Then I'm going to cut this circle up into pieces. I'll play around with how many parts I cut it up into in a second, but I'm just going to cut it into pieces. At this point, I have not changed the area at all. I've just cut the circle into 12 pieces. I'm going to spread those circle pieces out, little pi pieces out. So now they're laying on the floor. There's 12 of them. If I look at this distance along the bottom here, that whole distance is still the same as the circumference. It's 2 pi r, right? And the height of each of these little spiky things is the radius, because the distance from the outside to the center. Next thing I'm going to do is fold them back in on each other. So I'm going to take those blue ones, set them back in. The big key is, well, what shape did I essentially just make? Yeah, it's got some rounded edges, but essentially this is a parallelogram. The length of this whole thing here, right there, maybe, that's 2 pi r. When I folded it together, that's half as much. So this distance is just pi r. I've got pi r times r. Well, what is pi r times r? It's pi r squared. Now, at this point, it's technically not a parallelogram, right? It doesn't have straight edges. But watch what happens as I divide this thing into more and 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 more pieces. Those edges start to straighten out. And at this point, we haven't had calculus. We can't talk about how eventually, if I were able to divide this thing into infinitely many pieces, not only does that continue to be closer and closer and closer to a straight line, but with infinitely many pieces, it becomes a straight line. It actually becomes a rectangle, not a parallelogram. So that's where that whole thing comes from, of pi r squared as being the area formula. The circumference, or half of the circumference, times the radius. I can just write that out here. Right? Pi r times r, well, r times r is r squared, and that's our area of our circle. So let's just go ahead and do a couple of examples here. First things first is just finding the area of the circle. So I'm going to go ahead and write down my area formula. area equals pi times r squared. And I will plug in the things I know. Area equals pi times 7 squared. And again, we're going to split this up into two examples. I want an exact, and I want an approximate. I won't have you do both on every question, but I will tell you on this one, do approximation in terms of, or to the nearest tenth. On this one, do it exact in terms of pi. So if I'm doing it exact, all I'm going to do is simplify what I can simplify and leave the pi alone. And so in this case, well, the only thing I can simplify is 7 squared. 7 squared, or 7 times 7, is 49. And rather than writing it as pi times 49, just treat that pi like it's a variable and write it as 49 pi. If I'm going to do it approximately, I'm going to just grab Desmos, because why would I make this harder than it is? I need a calculator to do the pi anyway. I might as well just put the whole thing in my calculator. So I've got pi. Get this thing out of the way here real quick. And I'll go ahead and use the parentheses. Pi times 7 squared is 153.9, rounding it to the nearest tenth. 153.9. Come on. I still need units. So my radius was in inches, and now I'm finding area. So I've got inches squared, or square inches, preferably. And there we go. That's my exact. That's my approximate. Again, if I'm putting mulch in a circular garden bed, I want the approximate. Honestly, if I'm sending someone to the moon, I want the approximate, because 49 pi isn't a very useful number in real life. But for mathematicians and pure mathematics applications, we like that exact value because it's nicer for us anyway. So that's the two kind of solving for a circumference, solving for an area thing. Now, from there, the next place I would want to go is, can we use what we just learned with a little bit more algebra skills? So now if I say something like the area of a circle is 25 pi, find the radius, and then find the circumference. So we got to find the radius first. So this is an algebra problem, right? I'm going to start off with my area formula, pi times r squared, and plug in what I know. Now the area is 25 pi. That pi is part of the area. It cannot go away. You can't just write 25 or it's definitely going to be wrong. So we'll go ahead and write down what we've got here. 25 pi equals pi r squared. And it might look like with those pi's in there, it's going to be a little bit more difficult, but honestly, it's not going to be that bad. If I'm trying to solve for r, I got to start by getting rid of this pi. When I divide by pi on this side, and I divide by pi on this side, look at that, the pi's go away. So now I just have 25 equals r squared. And then I got to remember, well, what's the opposite of squaring something? It's square rooting. So when I square root r squared, I get r. When I square root the 25, I get 5. So my radius is 5, in this case 5 inches. I should always be writing my units in there because that's one of my answers. And then once I've got my radius, going back and finding the circumference is no problem at all, because circumference is just 2 pi r. And I'll plug in what I know, which is that r is 5. So 2 times pi times 5. And just like what we did with this first example, if I want this to stay in terms of pi, they started me in terms of pi, I'm going to stay in terms of pi. 2 times 5 is 10. Leave the pi alone because it's still there. And this is a linear dimension, so it's just inches, 10 pi. Last one here. The circumference of a circle is 16 centimeters, not 16 pi, just 16. Make sure you're reading the question. Find the area of the circle to the nearest tenth. In order to do this, we are going to first have to find the radius. So we're going to start off by going with our circumference formula because that's what we know. Circumference is 2 pi r, and I'll plug in what I know. 16 is my circumference, equals 2 pi r. Now I want to solve for r, so I need to get rid of this 2 and this pi. I could do this all at once if I wanted to, or I could do it in steps. I could divide by 2, pi r equals 8, and then I could divide by pi, r equals whatever that is. Or I could just do it all at once. I'll show you that instead. So I'll go ahead and just get rid of that. So if I do it all at once, I just divide by 2 pi divided by 2 pi. R equals. Now, if I'm going to just do this to the nearest tenth, I'm not going to leave the pi in it at this step just to put it, just to take it back out later. So this would be a good place to just say, okay, well, I've got 16 divided by 2 pi, and it is 2.54. I'm going to leave that value stored. I'll write it down as 2.5 centimeters right now and circle it. But when I go back to find the area, I'm not going to use 2.5. I'm going to use the stored value. So then I go over here. My area is equal to pi times r squared. I know my radius is 2.5. And so I'll just go ahead and plug that in. I know pi. I'm just going to use the pi button because I'm going to the nearest tenth. I know my radius, and I can square it. So I will go ahead and just take my calculator. I'll go pi. I'll go previous answer because that's the real value. I don't actually want to go 2.5. I want the whole value squared. And it's 20.37, which I'll write as 20.4. So 20.4 centimeters squared. One thing I want to make sure, I guess I mentioned right now, don't be comparing the circumference to the area. Sometimes the circumference measurement will be bigger than the area measurement, and sometimes the area number will be bigger than the circumference number. These are not comparable things. These are centimeters, which is a length. These are centimeters squared, which is an area. There's no reason to compare them. It's not like your area always has to be a bigger number than your circumference. It doesn't. On smaller circles, the circumference number might be bigger than the area number, but that's okay. They're not the same type of measurement. You don't need to be comparing them at all. So there's some examples on how to do those. Next thing we're talking about is composite figures.